Hello, it's Ryan here from RLF Vacuum Cleaners in Lakenheath, and in today's video we're going to be doing a repair and a brief talk about 110 volt transformers. So very simply, this is a 5 kVA transformer that I've picked up that I've got to do a repair for a customer. As you can see, the shutter door was broke and the plug and the cable was all damaged and taped up. So we're going to put a new cable on, new plug on, give it a quick check over, and then we'll add it to part of our maintenance plan, which we're going to do for this customer. So very simply, most of the screws at the top are missing, so we will be replacing them. So we'll unscrew that screw there, and we'll do the one back here. And we will lift the top off. I'll give you a quick look inside, so I'll move the camera. Now this is no ordinary 110 volt transformer. This is quite a high power one with a circuit breaker on the input and 2 circuit breakers on the output as well. So we'll be checking them as well. So what we'll do is we'll cut this cable tie off. Cut this cable tie off. Cut this off. Very simply, power cable comes in like here, it goes into this little connector block. So what we'll do is we'll use that connector block to be able to get to. Alright, so what we're going to do is use our Barco 1/4 inch socket set. Loosen that nut off. You can get to the circuit breakers. Make it easier to get to the terminal lock, but also make sure that the circuit breakers are tight. Over here. That's one. Hit the 2 serrated washers off. Move that to one side. What we're basically going to do, grab our terminal driver and just loosen off. Right, the earth wire goes into one of these double tags. Now I don't have another one of these double tags, so what we're going to have to do is we're going to have to cut that off, and we're going to have to connect it through a way or something. What we're going to do is cut it right here. so. Get the other end of the gland, put that back on. Now while we can get to the circuit breakers, right, now that we've got the circuit breakers out, we will grab our special tool, special screwdriver and terminals, and I'll just make doubly sure that they're nice and tight. Or in a situation like this, you use a torque screwdriver. I haven't got mine on me at the moment. So it doesn't all nice and tight. That's all good. Now this one's a bit of a different one to everything. It operates differently to everything else. This one has a circuit breaker on the input. It also has 2 circuit breakers on the output. You've got 13 amp. Don't know how that's going to come up on camera. But you've got a 13 amp one here on the input. And then you have 2 20 amp ones on the output. So we're tightening them all up. All good. What we're going to do is very simply, we're going to grab a new piece of cable. We're basically going to use an H07 RNF rubber flex cable. This is very heavy duty, ideal for building sites and things like that. What we're going to do is use the Knipex Ergostrip. Going to basically use the end like that, score, twist around and break it off like so. We're going to be using one of these orange perma plugs, brand new. Open it up like so. Open it like so. Going to loosen off the cord grip and turn it around, because when you're using this large cable, it's best to flip the cord grip around. The grip's better. Right, and we're basically going to loosen all these terminals off. Because we use a 1.5mm cable, we need to loosen them off all the way. Right, that's all done. Now all these perma plug ones, I give a little wire size cutting gauge. I tend to find that the live and neutral ones are pretty much bang on, but the other ones just ever so slightly a bit too short. So I'll grab our cutters and line the wires up. Out there. Neutral wire up there. Low wire there. Using the Ergostrip again. Strip that like so. Now, because we can, we're going to put some ferrules at the end, just to make it a little bit tidier. Now, I use these uninsulated 1.5mm ferrules. All ferrules are like a copper tube with a tin plating on. What they basically do is they take finely stranded conductors and make them into a solid strand. So when you tighten down on them, you don't break any of the fine strands. Come in very handy. You can get insulated ones as well. Honestly, insulated ones with colour coded shoulder on, which could be used, and the insulated ones, because in 13 amp plugs there isn't really much room for ones with the shoulders on. What I'm basically going to do is put that on there like so. And we'll grab our crimping tool. We'll just crimp like so. All that crimping tool does is very simply crimps that on, puts a little indent in it, so that won't come off. Do that for the other ones. There's been a lot of talk online about whether you should twist the strands. Now, if you're careful when you strip it, you don't splay the ends out too much. You can actually put them on without twisting. If you do get one where you splay the ends out, just a little twist will do. So, crimping tool, crimp it down like so. So I'll bring this to our plug. What we do is we'll lift the pin up, we'll put the earth one in first. So, grab our screwdriver, tighten it up like so. And we'll do the neutral one. This must be slackened off a bit more. We'll do the live one. Must be slackened off a bit more. Live ones are always a bit fiddly with bigger cables. But there's not a lot of rub. Basically put that in, tighten that up, tighten all the rest up. And the reason why we turn that cable grip piece around is because if you had it on the other side, you'd really struggle to get it over the rubber cable. Because rubber cable's got like a really thick, tough sheath on it, and if you had it on the other side, you really struggle to clamp that down. So if you turn it around, you get a bigger hole, clamps better. You don't end up bending and breaking the cord grip. So just it's a bit fiddly to do on camera. Now with these cord grips, you don't need to grunt them down with too much force, just enough so you can't pull it out, like so. And we'll put the top back on, put the cover back on, screw that down. That's reasonably, that's the plug end done. So we'll do the other end, go into the transformer, similar principle again. Stick it in there, twist it around, snap that off. Again, because we can, we'll put some 1.5 ferrules on. Please strip that off, put that there, like so. What we'll do is we'll put these black shouldered ferrules on, like so. We have a crimping tool, crimp it. So we get a nice close up of it, so you just put the ferrule in the tool like so. Then we just crimp it, like so. And what we'll do is we'll bring the transformer over and we will wire it up. Right, so very simply, we'll get the end of our wire, we'll push it through the stuffy gland. Normally on the smaller transformers, the stuffing gland will be on the inside, simply because to stop you smashing it off when you bash it against something, but this one's got a metal handle to protect it. So put that through like so, tighten that up, put wires back into the terminal block like so. We'll grab our terminal driver and we'll tighten them back up. Give it a quick tug test, quick pull, nice and tight. Tug test nice and tight. And then remount the circuit breakers. So put the locking washers back on. Put the nuts back on. And we'll grab our ratchet again, quickly tighten that up. Doesn't want to be too tight, just sort of tight enough that they don't move. Like so. And what we'll do is we'll strip these wires. Like so. And we'll use a Wago. Right, so first thing we're going to do is going to grab a cable tie. I'm just going to push it around the wire like this. Pull it tight. Basically what this does is an extra layer of strain protection, because in stuffing guns, if you do pull hard enough, you can actually pull wires out of them. Top tip when using cable ties: never cut cable ties with side cutters like this. They leave a sharp edge. You want some electrical side cutters, or any sort of side cutters where the jaws actually slightly overlap. They leave a really nice flush, non-sharp edge on them. So simply cut that off like so. Turn that around, turn that up nice and tight. Now there's absolutely no way in the world that that cable's ever coming out. Well, not under any normal operating condition. You'd have to really brutally force it out. Done like so. So now we'll do the socket on the front. Like so, because the shutter's broken and a bit wobbly, so we'll put a new one on. If you do a lot of electrical maintenance like me, you carry these panel mount 16 amp, 32 amp sockets all the time. So we'll grab one of that. Make sure you always get one with rubber gasket. Sometimes they come through with no gasket on. So we'll grab a screwdriver. We'll undo the 4 screws. Undo these 4 screws like so. Now these ones have a little nut on the back. We'll just grab hold of that. And we unscrew. What basically done is we have removed the socket like so. This one has these quick release ones on. I'm not a big fan of these. These aren't really, they're good for assembly but not very good for disassembly. Right, new screws and gaskets. New gaskets on the socket outlets. So what we're going to do is, after we do any complex repair like so, we'll give it a quick high current test. So what we're doing is we're going to plug it into there. We're going to grab our earth wire, connect that onto the top like so, turn the little knob to high current earth test, and we're going to test. And you can see we're getting quite a good reading. Hold it on for a couple of seconds. I'll do. So we're getting quite a good reading. We're getting 0.05 ohms, which is good. For something like this, we'd expect something less than 0.1 ohm. So a nice short cable. The earth is good. What we'll do is we'll switch around to the 500 volt line neutral to earth test. And as you can see, on the bottom scale, we're getting off scale. I'm doing a quick flash test, green light. What we're going to do is, quickly, we're going to make sure that the socket earth is there as well. They fit new sockets. So we've got a test probe, and we will stick the probe. We'll stick the probe in. So. Yes, got earth is good on that socket. I'll go with the other one. Yeah, the earth is good on that socket as well. So that there has passed the basic checks and is safe to be put out into use. What we'll do is we'll tag and ID it so it's identifiable in the future. And this is actually going out, so what we'll do is we'll put 3 months on this because it's all brand new cable and everything. We'll put 3 months on it. Recommend it be retested in 3 months. Next test we're going to do is do a functional test. Now for the functional test, what I've done is I've connected a couple of compact fluorescent floodlights up. These are better than LED ones, draw a bit more current. And a little tip when you work with 110 volt transformers is that if you plug them in with a load, and it stops some tripping circuit breakers sometimes. Circuit breakers on. You can see the lights and the circuit breakers will work. If you flip that one off, that light goes off. Flip that one off, that light goes off. And then flip that one, transformer goes off. That is one successful test of a 110 volt transformer.